So we are live. Hi everyone, welcome back to Codera. Today in this video we'll discuss the problem of the day, or we can say LeetCode daily challenge for today. That is 26th of December 2021, and the problem name is K closest points to the origin. So all those who can hear me and if my screen is clearly visible, so please consider giving me a quick +1 in the chat so that we can begin ahead with this problem. And apart from this, telling about this problem, that is k closest points to the origin. Like talking about this problem, that is k closest points to the origin. Okay. Yeah. So talking about this problem, that is k closest point to the integer. Hi Suman. Shiva Sarkar, some background noise. Is it still there? Is it still there? The background noise is still there. Now I might think that it must be okay. Scratching noise is k closest point to the origin, right? This is the problem, right? So basically I was writing on the pad, but actually it was not getting written, so that is why. Okay, k closest point to the origin. This problem has been asked previously in companies like LinkedIn, Amazon, and also LinkedIn, Amazon, and one more company, that is Microsoft, right? And many other companies as well, right? So just let me know if it is okayish or not currently. Like it is getting rubbed or scratched. I think that is on the writing pad, so I'll just try to see, try to think. Okay, so this question has been previously asked in LinkedIn, Amazon, and Microsoft. So these are the companies, the product based companies, and this question is rated as a medium one. Now this problem says is, I'll just read the problem statement for all of you. This problem says that you have been given an array of points where you have been given a point, that is xi and yi. You have been given a particular point, that is xi and yi, and this point represents represents a point on the xy plane, that is the graph, that is the plane of xy, and you have been also given an integer k, and you have to return the total number of points which are k closest to the origin, right? So the distance between 2 points on the x plane is the Euclidean distance, that is x1 square plus y1 square. You may return the answer in any order, right? The answer is guaranteed to be unique, right? So in this case, what you have to do is, let's suppose that you have been given these let's say you have been given 1 1 and -2 -2, right? 1 1 and you have been given -2 and 2, right? So let's say k value is 1, so you have to find the distance k closest points here to the origin, right? This is what you have to find in this problem, right? So it's good to see all of you in the solving these problem of the day today, right? So k closest point to the integer. So how do you find the distance? So there is a concept that is Euclidean distance, right? There is a concept that is Euclidean distance, and that distance is nothing but under root of, for any 2 points, that is x1 comma y1 and x2 comma y2, there is the Euclidean distance will be x1 square, x1 minus y1 square, x1 minus x2 square plus y1 minus y2 square, right? This will be the Euclidean distance, and since one point is 0 comma 0, so from origin you have to find for all other points. So from origin, for the point 1 and 1, the distance will be nothing but under a score of 1 square plus 1 square, that will be nothing but under root of 2, right? And this is under root of 2, right? After that, from 0 0, if I have to find the distance of the point -2, so what will it be equal to? So it will be nothing but -2 square plus 2 square, and that will simply give me under root 4 plus 4, that is under root 8. So I have to find the k closest. So in this case I have to find the the closest, right? I have to find the first closest coordinate from the origin. So what is the first closest coordinate to the origin? Can someone let me know in the chat for this particular problem? What is the k closest in this? Right, that is 1. If k is 1, then can I say that 1 comma 1 is the closest, right? From 0 comma 0, the k 1 comma 1 is the closest. Let's say I have some more points. Let's say I have this point 1 1. I was having this earlier as well. If I have 2 2, if I, let's say I am having a point, let's say 1 comma 2, I am also having a point, let us say that we have a point 3 comma 3, right? And if I say k is equal to 2, so this distance, the distance for this point from origin is root 2, the distance for this point is root 8, the distance for this point will be under root 5, the distance for this point will be 3 square plus 3 square, that is 9 plus this, that is 18. So if I have to find two closest points from the origin, so that will be 1 comma 1 because 1 comma 1 is at a distance of under root 2, and 1 comma 2 which is at a distance of under root 5, right? Other points are, this point is at a distance of root 8 and this point is at a distance of root 18, right? So I can easily say that if I have two closest points are this and this. So how can we do this? The first approach and the basic approach for this will be that you can use the first is this which part clear to everyone? I hope that it is clear. Now the first approach for doing such a problem will be that you will think that okay, let's sort, right? The first approach that will come in your mind is sorting, right? How you will sort? So basically you will say that okay, let's have all the distances 1 1 are the closest, yeah, right? So you will say that let us sort according to ascending distance, right? According to ascending order of distance, right? So that is Euclidean distance, right? And store the points that are there, right? For every pair, that is, you say that 1 comma 1 is at a distance of root 2, then you say that okay, 1 comma 2 is at a distance of root 5, right? Like this. 2 comma 2, you will say that it must be at a distance of, let's say, root 4 plus root 4, that is root 8, right? And let's say 3 comma 3, it will be at a distance of root 18, right? So you will say that okay, we will these are the two distances, and with respect to those two distances, the points will be what? The points will be 1 comma 1, you will insert them in a vector or a list and you will simply return them, right? Is this much part clear to everyone? For this, since you are sorting, so this will be n log n, right? That is the number of points that are given, and n log n, right? N is the number of points that are given. So let me show you the code part when you are doing it using sorting. So what you will be basically doing is, you will be having a function that is this function, and you will be given k closest. In this you will be given points, and you will be given the integer k. So what you will be doing is you will be simply sorting it according to the distance. And what will be the distance? Also you can say that the distance will be under root of a square plus b square, that is the xi square plus yi square. Or you can also say that you don't need to take the under root, since you are taking under root for everyone, so that is why it will not affect the final answer. So it depends on you. If you want to take the under root, then your array will store vector will store the data in the double format and not the integer. But I am using a vector int in which I am storing all the distances. That is why I've just squared them, right? So what I'll do is I'll simply sort them using this comparator. I'll usually just sort them using this comparator. That means that if the points are closer, that is this, if a particular point A is closer compared to the particular point B, then I'll sort it according to that manner. And in the end, what I'll do is I'll simply declare a vector of vector int, and in this I'll have all the points, and I will in the resultant vector I'll just return the first k points, right? First k points, that is from the 0th index up till the k minus 1th index, right? In this way I'll return, so I'll get the k closest point to the integer. Now this was the sorting part, but can we do something better than this? Yes, we can do something better than this. What better can we do? So let's say you are having some points. Let's take some more points for a better example. So let's say you are having 1 comma 1, you are also having 2 comma 1, let's say you are also having 5 comma 1, let's say you are having a point that is 1 comma 3, a point that is 2 comma 3 as well, and a point, let's say 3,3 as well, right? These are the points that you are having. Let me write their distances from the origin. So the distance of this point from the origin is root 2, the distance of this point is root 5, the distance for this point is under root of 26, the distance for this point will be under root of 10, the distance for this point will be 9 plus 4, that is 9 plus 4, that will give me 13. The distance for this point will be under root 9 plus 9, that is 18, right? So if I say that my k value is 3, if I say that my k value is 3, so I can do this using a priority queue. Using a priority queue, a data structure in languages that is implemented, that is also known as a priority queue. Also, you can like the video if you are liking the explanation. So I can use a priority queue. What will my priority queue do? So I can use a max heap. I can use a max heap, and what I can do in that max heap is, first of all, it must be clear that I am using a priority queue, and I'll tell you why, the reason why I'm using it. So if let's say the value of k is 3, that is I want to find the k closest points to from the integer, right? So that is 3. So what I'll do is I'll declare a priority queue, and in that priority queue I'll insert, every time I'll insert, notice that this is a max heap, right? This priority queue is denoting a max heap. Let me write it here again. Right, so this is declaring a max heap, max heap, right? So this will be denoting a max heap. So what I'll do is I'll insert elements up till when I'll insert only k elements in it, right? Every time not more than k elements should be there in the priority queue in this max heap, and whenever the number of elements are greater than k, so I'll pop those elements out, right? So what does that mean? Not more than k elements at a particular point of time should be there. So first of all, I'll insert 1,1, right? I insert 1,1, I see that its distance is under root 2. I insert 2,1, I am inserting in the order, right? So it is not sorted, right? Just don't think that it is sorted. These are the points that are given, and you can see that these are not sorted, right? I have not used sorting up till now. So okay, I have just used right in this way. After that, what I'll be doing is I'll be having a point 5,1, and in that I'll be having under root of 26, right? So you can see that you can see basically that these are the 3 points that I have discussed, that I have denoted, right? Right, these are the points that I have denoted, and after that what you can do is now you insert the next point, that is under root of 10, right? You insert the next point. Just give me a second. Okay, just give me a second. Right, so okay, so in this way you will be doing this. Now next up, what you can do is, next up you will insert the next element. What is the next element that you have inserted? You have inserted under root of 10, right? That is 1,3. So the number of elements are 4, right? But I am saying that let's not have more than k elements, that is let's not have more than 3 elements, right? So I will say that since this is a max heap, so which element will be at the top? 1,3 will not be at the top. The element at the top will be under root of 26, right? The element at the top will be under root of 26. So for this element, that is 5,1, that is under root of 26, this will be at the top, and 1,3 is here, right? So this gets heapified in itself. So that will basically take order of log k time for getting the heapified. That means the top, since this is a max heap, so the highest element, that is the largest distance, will be at the top. So this gets I will pop this out. Once I pop this out, so what I'll do is I'll insert the next element. What is the next element that I am inserting? The next element that I'll be inserting is this, that is 2,3. What is its distance? The distance is under root 13. So I insert this. So now my size is 4 again. So I see since the size is greater than k, that is 3. So what I'll do for this is I'll pop it out again. So since again it will get heapified, so this is a max heap, so the maximum distance will be at the top, so that is under root of 13. So under root of 13 will again get popped out, and once this gets popped out, so what will happen next is, let's say I am having a distance of let's say 3,1 again. Okay, if let's say I am having a distance of 3,1 and the distance is under root of 10, let's say under root of 11, I am having 3,2. So okay, let's say we have a distance of 2,1, right? If I have a distance of if I have point 2 comma 1, so the distance will be what? Under root of 5, right? So let's say I insert this point nextly, so I insert 2 comma 1 and its distance is under root of 5. So what do I see in this? I see that again the size is 4, so that means the size is greater than 3. So what I'll do is I'll simply pop out, but what will I pop out? So this will get again heapified and my largest element will get popped out, that is this. Since this is max heap, so my largest element will get popped out, that is 1 comma 3, that is under root of 10. So this will get popped out, and once this gets popped out, so in the resultant what I'll be having is I'll be having only these k 3 points, that is k points, that is 2 comma 1, which is at a distance of under root 5, 2 comma 1, 1 comma 2 as well, let's say this as 1 comma 2, right? 1 comma 2, 2 comma 1, right? 1 comma 2, let's write it as 1 comma 2, 1 comma 2, which is at a distance of under root of 5, and 1 comma 1 as well, which is at a distance of under root 2. So the reason for using a min heap max heap here is because if I am using a max heap, so the moment I get elements that are the size of the max heap greater than k, so I'll pop out that element. And since the max heap is always storing the top elements, so all the elements, all the n minus k elements which are there, which I do not want to consider, I want to consider all the k closest points, right? All the n minus k points which are not closer to the origin, all those points will get eradicated away, right? They will get moved away. So that is why what will happen, simply in the max heap only the elements that are k closest will be left. So for doing this, since you are doing this for n points, since you are having n points, right, so this will take order of n into log of k time. Why? Because you are doing it for all the n points, and at a particular point of time the size is not just k plus 1 or k, right? So for this you will take log k for heapify, right? That is for heapify, so that in the max heap always the maximum element stays at the top, right? Maximum element stays at the top. So let me show you the code part for this, for using a priority queue. What you can basically do in this part is, let me show you. Yeah, right. So this is a max heap. That means I am the largest element will be at the top. So what I'll be doing is I'll be having this function, and in this function I'll be given the points. So first of all, I'll be declaring a max heap, right, of pairs. That will store the pairs, that will store the points, that is xi and yi. After that, what I'll be doing is I'll be inserting the pair. That is, I'll be calculating the distance of the particular point from the origin, that is the Euclidean distance. I'll check if the max heap size is lesser than k, so I'll insert the current current pair in my max heap. Otherwise, if that is not the case, so what I'll do is if the current if I exceed, so in that case I'll pop out the maximum from it, and then I'll enter the next entry, right after that. What I'll be doing is once I'm done with that, so I'll declare a vector of vector int, and in that what I'll be basically doing is I'll basically this max heap will now contain only k closest elements from the integer from the origin, and in this way I can simply say that I'll be storing all these elements in the order, in the descending order. So all the points, all the k closest points will be stored in the descending order, right? This is how it will be working. Now there can be a third solution for this. Now there can also be a third solution for this. What can happen is you can also use a data structure that is known as multimap, right? In C++, multiset. You can also use a data structure that is also known as multiset. How does multiset helps me? So let's say this is point 1 comma 1, this is point, let's say 3 comma 3, then you have a point, let's say 1 comma 2, you have a point that is 2 comma 1, and you have a point 3 comma 1, you have point 1 comma 3, right? And let's say you have to find k is equal to 3, you have to find the k closest. So what you will be doing is you will be inserting. So what does a multimap do? So let's suppose that the distance for this is under root 2, the distance for this is root 9, the distance for this point is what? Under root of 10, the distance for this point is also under root of 10, but these are two unique points, right? So that what will multimap do, multiset stores in the form such that everything that is there in a multiset is stored in ascending order, right, in the set. But you know that in a set like under root 10 will be stored only once, but in a multiset under root 10, this under root 10 will also be stored, and this under root 10 will also be stored. Also all the things that will be stored in the multiset will be in sorted order, right, in ascending order. So what you can do is you can simply return the first k elements of the multiset, right? You can simply return the first k elements of the multiset. and in this way you will be able to get the final answer, right? This will also take order of n log n, that is the number of points that are available to you, and in this way also you can do it. So just you can consider giving me a quick +1 in the chat if this question is clear to all of you. And also one more thing, I'll be providing you with the link to the all the 3 solutions in the comments in the description of this video, so you can consider watching that as well. So thanks a lot everyone for watching this video. Also, if anyone has any doubt, so I'm here for 1 minute, you can just mention your doubt. So that's it for today, and I'll see you soon in the next video.